Alright, so we will be explaining the acceleration and how all that nice stuff works. So first there's two really equations that we use for acceleration. It would be A equals sigma F over F. And then A equals change in velocity over change in time.
Delta V over delta T.
Yeah, delta V over delta T. Thank you, cameraman. Will be seen later. So, right now, right here, this, sigma F, that represents the unbalanced force. And the unbalanced force is the force that causes the change in motion. So that'd be like, kind of like an object in free fall, kind of, because gravity is pulling it downward, so it's falling like a ball. It's falling down because the force of gravity is great that it's pulling it down, but there's no resisting force to keep it back up. There's no tension force or anything like that. So,
I mean, sometimes there's the force of...
like there's air force, but usually that's so minimal that we don't really count that. And then gravity is also kind of like a special case because it'd be A equals gravity, which is that is the mass. Gravity is the mass times like gravitational force, and then since acceleration is also divided by mass, that just kind of cancels out, so it would just be gravity, which is 9.8. So that's neat. And then up here, acceleration delta V over delta T. That just kind of is what it is, because it is velocity, change of velocity over time, how much velocity changes in usually a second. And then we're going to switch cameras.
Mm-hmm.
And now Luke takes the lead.
So now that you learn what acceleration truly is, now we'll finally learn how to use it in an actual problem.
Yep.
So, our problem will be a car, sorry for bad handwriting.
Yeah, it's fine.
Moving right 40 meters per second and comes onward to a stop in 5 seconds. Yes, it is a 5, not an S. What is the acceleration and why is it positive or negative? So now we will take what we learned before and apply it here. So we start out, initially we start our initial volume, so delta V could also be written as V final minus V initial. Taking that knowledge, and delta T is also time final minus time initial. Taking this knowledge, we know that velocity final equals 0 before it comes to a stop. Velocity initial would equal 40, as shown in the problem. Time Time final would equal 5. That's how much of time it takes. And we start time initial at 0, because that's what you usually start at. Now I need some more room, so I'm going to erase your wonderful acceleration forces. And let's put this to use. So final 0 minus initial 40 over final 5 minus initial to 0. Now basic math equals negative 45, which equals negative 8. We take that to...
Sorry, sir.
Now, with this -8, this is our acceleration. It's written as meters per second squared, or meters per second per second. The definition of acceleration is the change in velocity over 1 second. So at -8, the change of velocity -8 over 1 second. And that's what acceleration is.
Good.